Okay, so hi there everyone. We're now in our next video in college algebra, and here we're going to continue our discussion with the radicals, and this time we're going to talk about conjugates. Okay, on how to specifically how to simplify radicals with conjugates. Now, what are conjugates first? So the binomial quadratic surd, in which we're going to discuss a little bit or to define a little bit this word here, the binomial quadratic surd, just take note of this, square root of a plus square root of b and square root of a minus square root of b are what we call conjugates or conjugates of each other. A surd, by the way, is an irrational root of a positive rational number. So for instance, the square root of 2 is a surd because this is a positive rational number and the answer is irrational, meaning we cannot extract the values here. Square root of 3 is also a surd. So these are examples of surds. We cannot simplify them. But square root of 4 is not absurd, since square root of 4 is equal to positive negative 2. So square root of 4 is not absurd. Not absurd. Okay, so absurd is only this. It's an irrational root, the root that cannot be extracted from the radical sign of a positive rational number. So these are surds. So you can see these a here and b here are not perfect cubes, perfect squares, perfect numbers. Okay, perfect roots rather. They're not perfect roots. They are surds. They cannot be simplified. So square root of a plus square root of b, the conjugate of square root of a plus square root of b is square root of a minus square root of b. So to rationalize a fraction whose denominator is a binomial quadratic surd, what we'll do is multiply the numerator and the denominator by its conjugate. So its conjugate is something like the opposite sign of that number there. So to give you an example of one application of it, of the conjugates, so let's take a look at this example here. So we have 3 all over square root of 5 plus square root of 2. So remember in our radicals, we cannot have a rational or a radical in the denominator. So meaning square root of 5 plus square root of 2 cannot be or cannot stay there in the denominator. So what we're going to do is to multiply the whole equation by 1. So this is equal to or we don't need to do that. We will multiply this by its conjugate. The conjugate of this is square root of 5 minus square root of 2. And since we want to just multiply this by 1, so this becomes square root of 5 minus square root of 2. This is just 1 in a fancy way. So if we'll do this, let's just follow common maths. So in the numerator, we're going to distribute this 3 here to the square root of 5 and square root of 2. So what we have is 3 square root of 5 minus 3 square root of 2. In the denominator, we're going to do the FOIL method. So square root of 5 times square root of 5 is going to be square root of 5 times 5. That's going to be 25. Square root of 25. Square root of 5 minus square root of, or times negative square root of 2 is going to give us negative square root of 10. And then we have square root of 2 times square root of 5 is positive square root of 10. And then square root of 2 times negative square root of 2 is going to give us negative square root of 4. Take note the negative sign is outside. So let's simplify the denominators, especially. So what we have is, in the numerator, we cannot do anything about this, so just copy it as it is. So square root of 5, a little bit. Okay, so what we'll have is 3 square root of 5 minus 3 square root of 2. And then we can cancel the middle term actually. Minus square root of 10 plus square root of 10 is going to become 0. Square root of 5 is going to become 5. Square root of 4 is going to become 2. So 5 minus 2. Let's simplify that even more. So what we can see is 3 square root of 5. Maybe we can get the 3 out and get the common monomial factor, which is 3 square root of 5 minus square root of 2. What I did is I just extracted the 3 outside. And this is 5 minus 2, which is 3. Clearly, we can cancel the 3 and 3 here, which will give us the final answer, which is square root of 5 minus square root of 2. And that's our answer for number 1. Okay, square root of 5 minus square root of 2. Okay, so that's how you deal with conjugates. Let's proceed to number 2 now. So for number 2, what we have is square root of 3, or rather square root of 6 plus square root of 3 all over square root of 6 minus square root of 3. So we're going to multiply this by its the conjugate of the numerator, okay? So we won't do the conjugate of the numerator. So we'll do the conjugate of the denominator. So we have square root of 6, okay, plus square root of 3. Okay, all over, or rather, the numerator is square root of 6 plus square root of 3. Okay, so this should be equal to 1, right? So doing the maths normally as it is. So this is actually a binomial, square of a binomial. Square root of 6 times square root of 6 is going to give us square root of 36. Square root of 6 times square root of 3 is going to give us plus square root of 18. Square root of 3 times square root of 6, we're in the I now in the FOIL. That's still positive square root of 18. And we have square root of 3, the last, square root of 3 times square root of 3 is going to give us plus square root of 9. Now all over, FOIL first, square root of 6 times square root of 6 is going to give us square root of 36. Outer, square root of 6 times positive square root of 3 is going to give us positive square root of 18. Inner, negative square root of 3 times square root of 6 is going to give us minus square root of 18. Minus square root of 18. And last, square root of 3 times positive square root of 3, or negative square root of 3 times positive square root of 3 is going to give us negative square root of 9. Hence, what we have here is going to be simplified the numerator. So what we have here is 36. The square root of 36 is 6. We have here square root of 18, both of them, so we can add, which is going to become 2 square root of 18. Square root of 9 is 2, so what we have is this one. In the denominator, what we have is 6. Square root of 36 is 6. 18, square root of 18 minus square root of 18 will be cancelled up. It becomes 0 minus square root of 9, which is 3. Further simplify, 6 plus 2 is going to give us 8. 8 plus 2 square root of 18. This becomes 6 minus 3 is going to give us 3. Okay, it's going to give us 3. Okay. Um, oops, sorry. This should be 3. My goodness. This should be 3. My bad. Square root of 9 is 3. My bad. Okay, so this should be 3. With that, 6 plus 3 is going to become 9 instead of 8. I'm sorry. Okay, so this is 9 instead of 8. Okay, so this is a 9. Okay, so this is a 9. Just believe me that this is a 9. Okay, so this is messed up. So 9 plus 2 square root of 18. So that's our answer there. Okay, so then what we're going to do is we're going to tweak something with the square root of 18. There is a perfect square for square root of 18. That is 9. So let's get that out. What we have is 9 plus, sorry, 9 plus 2 square root of 9 times 2, which is 18. Oops. All over 3. 9 times, square root of 9 is 3. So this gives us 9 plus 2. Square root of 9 is 3 times 3. Square root of 2 all over 3. 2 times 3 is going to give us 6. So we have 9 plus 6 square root of 2 over 3. Let's get the common factor of 9 and 6. That's going to be 3. 3 times the quantity of 3 plus 2 square root of 2. How did we get this, sir? Because 9, recall 9 as 3 times 3, right? Recall 6 as 3 times 2. So both of them have a common factor, which is 3. So what we're going to do is by common monomial factoring, we'll get the 3 out. Thus, we have this one. So since the 3 is out, we can cancel the 3 with our denominator 3, which will eventually give us our finalist answer, which is equal to 3 plus 2 square root of 2. Okay, 3 plus 2 square root of 2. And this is our final answer then. Okay, this is our final answer then. 3 plus 2 square root of 2. Okay, so that's it for this video. of a radical of conjugates in radicals. So this will give us then, okay, this will give us, I will give you rather an assignment to work on. We will answer this in the next video. So as an exercise for everyone, we have here as an exercise for our number 3, we have 2 plus square root of 3 all over square root of 5 minus square root of 3. Again, we have 2 plus square root of 3 all over square root of 5 minus square root of 3. So this will serve as your assignment, and we will be answering this in the next video. This is going to be a short video in the next. So thank you very much for watching. Hope that you would like and subscribe, and see you in the next video to see the solution here. Okay, so see ya.